Hi, welcome. My name's Steve. I'm a former maths teacher, and I'm about to have a go at the Junior Maths Challenge in 2020, the one that was sat just under a year ago. We're going to have a go through all 25 questions. We're going to try and answer them all, and then at the very end, we're going to mark it as well. So if you just tuned in and you want to have a go yourself, in the link under the video, this is on YouTube, and the link under the video, there will be a link to the paper itself, and then on the same website there are solutions, but you can wait to the end of the video and I'll go through the solutions. So if you want to have a go at yourself, open that link up, pause the video, and then have a go yourself, and then you can see how you did compared to me. And if you've done these before, you'll know what you're doing, but if you haven't, there's some instructions on the sides. If you're a year 7 or 8 student who is about to do this for the first time or something like that, the instructions on the front of the paper, make sure you read them. Make sure your teacher will probably go through the key points anyway, but usually if you're a year 7 or 8 student and you're not a brilliant mathematician, you'll all be pretty good if you're doing this, but don't expect to be able to do every question. So that's the key bit here. Some of them are difficult. Some of them, if you don't spot a quick way of doing it, will take you a lot of time and you might not finish. So they get more difficult as you go through it, like most papers do. And the way it's scored, now it keeps changing year to year, but the way this particular paper is scored that I'm doing now is that every question for the first 15 is worth 5 marks, and every question thereafter is worth 6. And in this particular paper, which I believe is first for the junior ones, I think usually you would lose some marks. In this particular one, you get you don't lose any marks for getting questions wrong. So if that is the case in your actual one, don't guess any questions till right near the end, and then at the very end, have a guess at anything you couldn't do, if that's the case. So, but never guess if there's, often the last 10 questions you often lose marks for. So if that's the case, don't guess on any of the ones you got wrong, because they're really good at putting good wrong answers there. They'll pick answers that if you've gone wrong, you'll get. And this last thing is, this style of paper is different to any sort of maths you'll ever do in school. Obviously, you'll use the maths you do in school to solve this sort of stuff, but the style of questions they do, the types of questions they do, are a lot more abstract than your regular thing. They'll make you think. They'll be nice and trick, and if you get to the point where you really love maths in the future, you'll find it all elegant and really nice. So it'll be different. Don't feel like you're stupid because you can't do them. It's just because you've not met these questions before. If you're someone like myself or someone else who's doing these for fun at a later date, take as long as you want. The real exam you'd have 60 minutes, but we're going to take as long as it takes to answer all the 25 questions. And at the very end, we're going to mark it. If you get a score at the very end of yours and you want to post that score, again, just post it in the YouTube video below, see what you got, and we'll see what we got. It's going to be out of, what's it going to be out of, 25? 135, I think. So what score did you get out of 135? Feel free to post it in the video in the comments below. And all in all, let's just have a bit of fun. So we're going to move into the video. I am recording this on Twitch, so this is live on Twitch. So if you're watching this on YouTube and I suddenly stop and start talking to someone, it's because someone on Twitch at the time is going to be talking to me. And I will often read out what they've said, so it's not completely out of the blue. But so forgive me if I take long on some questions because I'm chatting with people. But let's go. Right. Exactly one of the following 5 numbers is not prime. Which one is it? Let's have a quick look. So I think I know this just from multiplication, but I believe it is that one. There's a couple of ways you can do that. You can know that is 3 37s, I think. I think 3 times 37 is 101. The other thing you can do is divisibility tests, and one of the quickest divisibility tests, often with all these numbers here, you know one of them is divisible by 3. They missed out 105, but you know one of these is divisible by 3. The 3 times table will be going up in these, and so if you know your divisibility test for if it's divisible by 3 or not, you know if you add the digits up and it's a multiple of 3, then the original number is divisible by 3. So in this particular case, 1 plus 1 plus 1 is 3, which is in the 3 times table, so that will be a multiple of 3. What is the value of 2020 divided by 20? Well, there's 100 20s in 2000, and there's 120 in 20, so I believe it's 101. Each of these figures is based on a rectangle whose centre is shown. How many figures have a rotational symmetry in order of 2? So The dot isn't part of it, but it shouldn't matter because it's in the centre anyway. How many figures have rotational symmetry of order 2? So this means that it will, if you rotate it, if you start rotating it in a circle, it will look like the initial shape at 2 points. At the very end, so everything will always have an order of 1, and then halfway round. So if we rotate these 180 degrees, will they look the same as the original? So this one will. This one won't, because you'll have the V pointing the other way around. This one won't, because you'll have the line here. This one will, because this corner will be here, and then this corner will be here. So you'll still get the line going the same way. And this one will, again, you'll have the line through the middle. Instead of going left to right, it will go right to left. So that one is, and that one is. So we think it's 3. And more importantly, this one doesn't have an order of 4 because it's a rectangle, and if you go 90 degrees it will be sideways on, it won't look the same. If these were squares, this one wouldn't count because this would not have an order of 2, it would have an order of 4. That's not what we want. How many centimetres are there in 66.6 metres? So that's metres. To get from metres to centimetres, there's 100 centimetres a metre, so we're going to times that by 100. It's going to be 66,600. No, it's not. It's going to be that. Oh, that was almost a mistake. Bad maths there. Amrita thinks of a number. She doubles it and adds 9. She divides her answer by 3 and finally subtracts 1. She obtains the same number she originally thought of. What was Amrita's number? So there's a couple of ways of doing this. One of them is you could try picking one of these numbers and going through that process and see if you get back to what you started with. But we're going to do this algebraically. So Amrita thinks of a number, let's call it x. She doubles it. She adds 9. She divides her answer by 3. And then finally subtracts 1 from it. And she gets the same number she originally thought of. Now she thought of x, so she gets back to x. Now all we're going to do is rearrange this. So we're going to say 2x plus 9. We're going to add 1 and times by 3. So it's going to be 3 lots of x plus 1, or 3x plus 3. So 2x plus 9 equals 3x plus 3. So 9 is 3x is x plus 3. 6 is x. So we think it's 6. Now how do we check our answer? Well, we're just going to go through it and go through this in head. So Anita thinks of a number, we're going to think of 6. She doubles it, 12, adds 9, 21, divides her answer by 3, 7, take 1, 6. That works. Sorry, AJ, I started about 8, but the first few were quite quick. Did you want to check any of them, or are you happy? I mean, you'll get those right. I don't think we need to check them all. What is the value? But welcome anyway, nice to see you. What is the value of 6 twelfths, take 5 twelfths, plus 4 twelfths, take 3 twelfths, plus 2 twelfths, take 1 twelfth. I'm just going to put these into pairs. So there's a pair, and there's a pair. And each of these pairs will get an answer of 1 twelfth. So the person who's watching is called AJ. Hi AJ, this is for YouTube. AJ's done his questions, he hasn't checked the answers, so he's going to watch me potentially struggle. So we've got 1 12th plus 1 12th plus 1 12th is 3 twelfths, which simplifies to 1 quarter. You could have done 6 take 5 plus 4 take 3 plus 2 take 1, which would get you 3, and it would be the same. 4 different positive integers, so they're all different, have a product of 110. What is the sum of the 4 integers? So 110 is going to be 10 lots of 11. It's going to be 2 lots of 5. So 2 times 5 times 11 is 110. And to get 4 different positive integers, the last one would be 1. So we've got 1 times 2 times 5 times 11 is 110. And because 2, 5 and 11 are prime, there'll be no other way to do this, and you need a 1 there, otherwise you haven't got 4 different integers. So we think it's that, and so then if we add, the sum means adding them together. we get 11, 16, 17, 18, 19. We think it's 19. Is that an option? Yeah. Now, if you haven't seen me do these before, I rarely look at the answers until I've had a go at the question. So in this particular case, I will do it. I'll get an answer and then I'll see if it's there. If you start looking at the answers to see what's most likely, that's where they start getting you with their wrong answers. They're very good at picking wrong answers, so be careful. Wesley has a grid of 6 cells. He wants to colour 2 of the cells black. So the 2 black cells share a vertex but not a side. In how many ways can he achieve this? So we're looking for different ways of shading black. So a vertex means a fancy way of saying corner. It's where 2 edges meet, but not a side, so not an edge or not a side bit. So if we paint, so let's say if we paint this one black, it's this one, so that's 1. So that's got 1 possibility. If we paint this one black, you've got 2 possibilities. If you paint this one black, you've already got that possibility. If you paint this one black, you've already got that possibility. If you paint this one black, you can have this one as well. So what I'm trying not to do is count them. So we've got those, 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 and those. I think that's 4. Oh, we've got these as well. Yeah, I missed that one. Yeah. So you've got kind of 4 ways of doing those, plus this pair here. They show a vertex but not a side. So we think it's 5. One half of 1/3 of 1/4 of 1/5 is the number 2. What is the number? So we're just going to work out reverse. So basically, yeah, so AJ says he really likes drawing the diagonal lines there. Effectively, every line you draw is a pair of squares, and you have 5 diagonal lines. So that was 5 pairs of squares that fit. 1/2 of 1/3 of 1/4 of 1/5 of a number is 2. So the couple ways of doing this, you could say x is my number, and 1/2 of x is times by 1/2, and then 1/3 of x is times by 1/3, and 1/4 of x, and so on. You could do it that way. And then it equals 2, and you could rearrange it. But we're just going to work out in reverse. We're going to say if our number's 2, that is 1/5 of 10. And to work out, we're going backwards. Instead of 1/5 means divide by 5, so to work backwards, we're going to times by 5, and times it by 4, and times it by 3, and times it by 2. And if we do it that way, we'll make the numbers easier. It's easy to multiply by the larger numbers first. So 2 times by 5, times by 4, times by 3, times by 2. That is 120. I'll make that clearer. So 240, my number is 240. I'll turn my phone on silent, so my staff are pestering me. Right, how many of these equations have the solution x equals 12? So we're just going to have a look at each of them and see if 12 works. 12 take 2 is 10, that works. 12 divided by 2 is not 24. 10 take 12 is not 2. And 2 times 12 take 1 is 25. Well, 2 times 12 is 24, take 1 is 23, so that doesn't work either. We think it's 1. This 3 by 3 grid shows 9 1 centimetre by 1 centimetre squares and uses 24 centimetres of wire. What length of wire is required for a similar grid, a similar 20 by 20 grid? Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So each of these is 3 centimetres long. You've got 8 3s is 24, so that works. So if we have, I assume a similar 20 by 20 grid. I don't like the use of the word similar here, because similar is an enlargement. I think they're not using this in the context of the maths here. I think the grid, the 20 by 20 grid, will be 20 1 centimetre squares. So if you have 20 squares, you will have 21 lines going down. And if you have 20 squares in rows, you'll have 21 lines going across. So we've got 21 lots of 20 centimetre rows. So imagine this one is, each row goes 20 long, and you've got 21 pieces of wire, and you've got that many rows, but you will also have that many columns. And then the total length of the wire will be this times this, plus this times this. So 21 times 20 is 420 centimetres. So we think it's 840. I can see 800 is a good wrong answer there. 800 is a good wrong answer. Because you'll think 20 by 20, well, I'm going to have 20 rows and 20 columns of 20 centimetres each. The diagram shows an equilateral triangle divided into 4 smaller equilateral triangles. One of these triangles has itself been divided into 4 smaller equilateral triangles. What fraction of the area of the large triangle has been shaded? So this bit is 1/4 of the original, and the shaded bit is 3/4 of that. So we're looking for 3/4 of 1/4 of the whole shape, which is going to be 3/16. If that makes sense. The other way of doing this is that if you get you're not allowed a ruler, but you're allowed to draw straight lines. So you're allowed something that draws a straight line, but you can't have something that measures. So if you split them all, like you've split this one here, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 little triangles, and of those 16, 3 of them are shaded. That's another way of doing that. The mean of 4 positive integers is 5. The median of the 4 integers is 6. What is the mean of the largest and smallest of these integers? Okay, so if 4 positive integers have a mean of 5, you know that 20 is the overall sum. You know they add up to 20. And the median of the 4 integers is 6. So we know that plus that. So if these are your 4 digits, you know that these two have to be 5 and 7, or 6 and 6. Oh yeah, 6 and 6, 5 and 7, 4 and 8, and whatever. So you need the median to be 6 when you put them in order. So because these two, whatever they are, will add up to 12, you know that these two must add up to the remaining 8. So you could have 1, 6, 6, 7, that would work, or 2, 6, 6, 6, that would work as well. But whatever happens, the two end ones have to add up to 8, because the middle two will add up to 12. So the mean of the two edge ones will be 4. It'll just be the average of the two edge ones. We don't know what they are. I think you've only got 3 options. You can have 1, 6, 6, 7. You could have 1, 5, 7, 7. Or you could have 2, 6, 6, 6. I think they're your only options for them, actually, because bear in mind that you can't have, your end number can't be higher than this one, so I don't think 8's a possibility. In the diagram, angle OLM is twice as large as angle PON. What is the size of angle OLM? So OLM, the way that it works, if you've not seen this before, OLM is the angle made up by lines OL and LM. It's the angle at L that's made up of the lines OL and LM. So OL is this line, LM is this line, so it's that angle there or that one. So we're trying to work this one out, so we'll call it X. I probably should have drawn this diagram a bit larger, but what is the size of the angle OLM? It's twice as large as the angle PON, so it's twice that. That is half x, x over 2. Okay. Okay, so we can work it out. So what we're going to look at this middle triangle here. There might be another way of doing it. So K, L, O. We're going to look at that triangle there. I'm going to draw it out slightly larger. We know that if that is x over 2, that is x over 2. So that is x over 2 as well, because they're opposite angles. If that one's 124, then this one can be worked out. So this one's going to be whatever makes 180, so it's going to be 56. And if that is x, then this is going to be 180 take away x. That's going to be 180 take x. And angles in a triangle add up to 180, so we know that 56 plus 180 take x plus x over 2 equals... so AJ said he didn't spot that 124 was written on the diagram. He says usually in the question they will tell you. I agree with that. Usually in the question they will tell you all the angles and all the information. Yeah, so that's not great, is it? Is 180. So we can take off 180 off both sides. You've got 56 minus x plus x over 2 is 0. If you double it, you get 112. Take 2x plus x is 0. So you've got 112 take x is 0. So x is 112. I'm sorry, I will move. I realise my head's in the way of this, isn't it? Oh no, I'm just out of the way. I thought I had drawn behind my head and I haven't. Yeah, I'll be aware of that for future questions. Group of 42 children all played tennis or football, or both. And the same number played tennis as played just football. Twice as many played both tennis and football as just played tennis. How many children play football? So I'm just going to, I don't know whether this is the best way of doing it. I'm going to draw a Venn diagram. And we're trying to work out, we're going to say that's tennis and that's football. And we know that we are trying to work out how many of the children play football. We're trying to work out this bit here. So we know whatever number goes in. So the same number played tennis as played just football means in the tennis circle has to equal whatever this is. So in the whole tennis circle, there has to be x, and equals just what football is. Twice as many play both tennis and football as play just tennis. So that's 2x. Same number play tennis as play just football. Oh, twice as many play both tennis and football. I missed doing this. Let's go back. Twice as many play both tennis and football as just play tennis. So we know that if tennis is y, twice as many play both tennis and football, so that's going to be 2y. So we know that from the 2 bits of information we've got, so basically they're saying just football is the same as all of tennis, so that's x and x, and we know tennis and football is twice as many as just tennis. So we have 2 equations here. We know we've got a few. Actually, we know there's 42 children. Yes, there's 42 children in both bubbles, and the both bubbles is made up by 2x. So we know 2x is 42. So x is 21. And we know that 3y equals x from this bit of bubble here. So we can say 3y is 21, so y is 7. So let's just double check this is right then. So we think that's 7, that's 14, and that's 21. So does that work? Twice as many play both as just tennis. The same amount as play just football as tennis altogether. So that works from the information. And 7 plus 14 plus 21 is 42. So how many of the children play football is 14 plus 21 is 35. I might not have done that the most elegant way. There's probably another way of doing that. But we got that. You were given the sequence of digits 0, 6, 2, 5 and can insert a decimal point at the beginning or at the end or any of the other 3 positions. So we can put it in one of these 5 places. Okay. Which of these numbers can you not make? So 0.625 is 5/8, so we can make that one. 0.0625 is, I think that's 1/16. 6.25 is 6 1/4, which is that one. 62.5 is not listed, and 625 is 25 squared. So I'm just going to double check one thing. I'm going to do how many 16s in 1 and try and get 0.0625. So how many 16s in 1 doesn't go? Carry 1. How many 16s in 10 doesn't go? Carry 100. How many 16s in 100 is 6, carry 4, because 6 16s are 96. How many 16s in 40 is 2, carry 8. And how many 16s in 80 is 5. So that works. So I was just double checking that was 0.0625, but I believe that the answer was that. Which, if you're looking for wrong answers, it's got a 625 in your answer, and there's a 625 here, so it's probably a wrong answer to make people think it's possibly right. In 1925, some Polish gentleman, that I'm not going to try and pronounce, probably, published a rectangle that can be dissected into 9 different sized squares as shown in the diagram. The length of the sides of the square are 1, 4, 7, 8, 9, 10, 14, 15, 18. What is the area of Moron's rectangle? So if I write the number, so that's clearly 1, 2, 3, 4, so 1, 4, 7, 8. So yeah, 1, 4, 7, 8, because 1 and 7 make 8. 1 and 8 make 9. 9 and 1 make 10. 10 and 4 make 14. 14 and 4 make 18. And this little bit's 3 because of the 4 and the 7. So 18 take off 3 is 15. So that works. What is the area of this rectangle? Yeah, rectangle. So you can see this isn't a square, because if these two are 18 and 15 and these two are 18 and 14, you can see that the whole shape is not a square. It's just an ever so slightly off square. It's a rectangle. So we're going to do 18 plus 14 is 32, and 18 plus 15 is 33. So the area of the whole thing is 32 times 33, which is, that's 32 squared, so it's this one. 32 squared is 1024, so we need one more 32 to get 1056. But you could just multiply those out using the grid method or something. So AJ did another one. So AJ did, on this last one, he said 6 out of 25 is the same as saying 24 out of 100, which is 0.24, which is not makeable by that. So that's quite nice. I'm a general fan of not looking at the answers unless the question asks me to. So in this particular case, I just saw what fractions I could make with this, and then just eliminated them when I could. But yeah, your method's fine as well. If you just want to look at the answers, that's another way of doing it. Oh, Lister, apologies. Sorry, Lister. Yeah, so apologies. That's from Tim. So Tim said that way. Yeah. It's just not my style, Tim. It's probably what you did is quicker, definitely. As long as you spot the right one to try. But it's just not my style on these. How many 2-digit primes have both their digits non-prime? Oh dear. So you can't have any starting with 1. You can have some starting with 2. So you've got 20. I'm just going to list these. You've got 23, 25, 27, 29. No, you can't have 29. Because although 29 is prime, 9 isn't. You can have things starting with a 3. So you can have 31 is prime, but 1 doesn't count. 33, 35, 37, 39, 9's not prime. You can have 4, you can't have 4, you can have 5, you can have 50, 51, no, 53 is prime, 57 is prime, I think. No, 57 is not prime, that's 3 19s. Yeah, I don't like this, there might be a nicer way. 59, 9's not prime, so 60, 70, you can have 71 is prime, no, 71's not prime, no, is it? Ooh, I'm missing some. Oh no, yeah, I can't have anything ending in a 2, can I? So 72. Yeah, it's not prime either. 73 is prime. 75, 77, 79 is... I can't have 9. 80, 90, so I think it's 4. So it can't be 1. It can't be 21, 25, 27 or 29. In fact, I'm just looking for combinations of 2, 3, 5 and 7, and once I've gone through the 20s I can't have anything ending in a 2, so if I check the 20s I can only get 23, then every other one must be a combination of these 3 because it can't end in a 2. So you can have 37 but not 35, you can have 53 but not 57, and you can have 73 but not 75. So I think it's 4. I think that's a better way of just checking. Yeah, I think that's probably the quickest way of checking, realising that they can only be made up of those 4 digits, and once you've checked the ones starting with a 2, you can't have any more 2s. So then you've only got 6 combinations to check. You've got all the combinations 3, 5, 3, 7, 5, 3, 5, 7, 7, 5, 7, 3. So you check the 20s and then you check those 6, and that might be the quickest way of doing it. In the table shown, the sum of each row is shown at the right of the row. Did you do that wrong? It says both digits non-prime. Yeah? Oh. Apologies. Yeah, we would have got this wrong. Thanks, AJ. We want the other way around. How many 2-digit primes have both their digits not being prime? Okay, so we're actually doing it the other way around. We're actually looking for all combinations made up of 1, 4, 6, 8 and 9. Good spot. So I would have got that wrong. So you're looking for, starting with 1, you can have 19. So we've got 19. Starting with 4, you can have 41. The 49 isn't prime. Starting with 6, you can have 61. 69 is not prime. Starting with 8, you can't have 81 because 81 is 91. So I think it's 3. Actually, because 91 is 7 13s, 81 is 9 9s, and you can't have anything ending in 9. Oh, yes, you can. Yes, you can. 49, 69, 89 is prime. So weirdly, oh, I was very lucky there. I think I get the same answer. Oh, and 91, 99, yeah, okay, just check those. Yeah. So I think I get the same answer. Oh, I'm going to go with it. I would have got it wrong. I'm happy I got the same answer because I would have got it wrong the other way around. Apart from I would have fluked it. Yeah, you read the question right, so well done, AJ. In the table shown, the sum of each row is shown to the right of the row, and the sum of each column is shown below the column. What is the value of L? So right, so I'm going to look at this column and this row. So we know that 2, oh, it's the same thing, isn't it? 2L plus J is 15. So I'm going to look at this one and this one. I'm trying to ignore one letter and give me 2 sums. So this is called a simultaneous equation. We know 2J's plus a K is 5, and we know 1J plus 2K's is 7. So simultaneous equations, I'm going to double the second one. So 2J's plus 4K's is 14. And then I'm going to subtract the top one from the bottom one. So we're going to do 2J take 2J is no J. 4K take K is 3K. 14 take 5 is 9, so k is 3. So once we've got one of them, we can work out the other ones. So let's go back and fill it in. So if k is 3, j has to be 1 and 1. 3, 1. So you can see that works. If j is 1 and k is 3, it works. And if j is 1 and k is 3, so 6 of 13, L has to be 7. Just double check that works for all of them. 7 plus 7 is 14, 15. 7 plus 7 is 14, 15. 7 plus 3 plus 3 is 13, so that works. So what's the value of L? L is 7. Oh, I've missed one out. Yeah, okay, so I'm going to count this as wrong. I missed 11. They could be the same digit, so it's actually going to be that one, but I'm going to count that as wrong. I got it wrong twice, effectively. Edmund makes a cube using 8 small cubes. Samuel uses cubes of the same size as the small cubes to make a cuboid twice as long, 3 times as wide, and 4 times as high as Edmund's cube. How many more cubes does Samuel use than Edmund? So Edmund's cube has a volume of 2 by 2 by 2. And Samuel uses cubes of the same size as the small cubes to make one that's twice as long, so 4 times as long, 3 times as wide, so 6 times 6 wide, and 4 times as high, so 8 high, to make his cuboid. And the volume of this cuboid is 8 times 4 is 32, times 6 is 192. So this is made up of 8 1 centimetre by 1 centimetre by 1 centimetre cubes, and this made 192. How many more cubes does Samuel use than Edmund? So if we take 8 off 192, we get 184. The digits of both the 2-digit numbers in the first calculation below have been reversed to give the 2-digit number in the second. So 62 is 26, 13 is 31, and it gets the same calculation. Which one of the calculations below is the same thing true? So we could just work this out. We could just work this out. Is there any I can eliminate so I don't have to try them? So I can eliminate this one, because if you reverse the digits, you're going to get 50 something times 60 something, which is going to be way higher. So it can't be that one. I think it's this one, actually, but for the same reason it can't be this one, because if you reverse the digits, you're going to get something. You're going to get 23 times 34, and both of those numbers are smaller than the starting one, so it can't be that one. I think it's this one for a weird reason. If you reverse the digits, you get 24 times 84. But another way of doing it is if you half this one, if you half this one and double this one, you also get that, but the other way around. So 42 times 84, if you reverse the digits, you get 42 times 48. If you reverse the digits, you get 24 times 84, which you can see that another way of doing it. So for example, if you're trying to do 14 times 15 and you don't like it, if you half one and double the other, you will get the same answer. So 14 15s, I'm not sure, maybe my maths is bad, but I know that's 210, which means that's 210. So in this particular case, 24 times 84 is that little trick. You've doubled 42 to get 84 and half 48 to get 24. So I think, without even working the answer out, it's that one. If you had time at the end, this is definitely one you could just sit down, you could do long multiplication for whichever ones you want to try until you got ones that worked. Harriet has a square piece of paper. She folds it in half to form a rectangle, and then in half again to form a second rectangle, which is not a square. So what you're not doing, if she's folding in half that way, and then she's not folding the resultant half down. So she's folding in half that way, but she's not folding it back down because you'll get back to a square. So it looks like she's folding in half, and then once she's folded in half this way, she's got to fold it in half again. So we're looking at a string this thick. So we're looking for our original square is going to have the perimeter of the second rectangle is 30. What is the area of the original square? So our second rectangle has a perimeter of 30. So let's say that x is the length. Now I'm just going to make it easy for myself. Let's say that 4x is the length of my side, which means this top edge has been folded half twice. So that must be x. 4x, x. The perimeter of this is 10x. Is 30 centimeters, so x is 3. So my original square was 4x, which remember x is 3. My original square is 12 by 12. So it's going to be 144. AJ misread this one too. Yeah, there's only two ways to fold. There's only one way to make the initial fold, and there's only two ways to make the second fold. One of those gets you back to a square, which you're not allowed. I imagine you maybe misread the perimeter, one's area. There is more than one integer greater than 1, which leaves a remainder of 1 when divided by each of the 4 smallest primes. What's the difference between the two smallest such integers? Okay, hang on, you didn't. What have I done it wrong? I think I've done it right, so I'm going to leave it. What is the difference between the two small such integers? So there'll be an infinitely many integers that satisfy this bit. So if you're looking for the 4 smallest primes are 2, 3, 5, and 7. So we're looking for a number that's 1 bigger than a number in each of these times tables. So if the smallest number that's in all 4 of these times tables is 2 times 3 times 5 times 7. So 2 times 3 is 6, times 5 is 30 times 7. Weirdly, it's 210, which is the one we just worked out. And we know that 210 is in all of these times tables, which means 211 is the smallest number that will get you a remainder of 1 when you divide by each of these. And any multiple of this, the next number that's 1 bigger than each of these, will be 210. It will be the second number in the 210 times table. So if you imagine 210, 420, 630, and so on, all of these numbers in the 2, 3, and 5 and 7 times table. So 1 more than all of these numbers. 8, 4, 1, and so on. 1 more. All of these satisfy this. So basically, if you keep going up in 210s, you'll get another number that satisfies this condition. And if they're all 210 apart, then the difference between the two smallest integers, i.e. the difference between these two, is 210. Susie is attending a talk at her son's school. There are 8 rows of 10 chairs where 54 parents are sitting. Susan notices that every parent is either sitting on their own or next to just one other person. What is the largest possible number of adjacent empty chairs in a single row at the talk? So I'm just going to assume. So let's say I've got my. Can I undo? Can I put a table in? Some table. I'm going to have something like this. Can I shrink it? Yeah, so this is my thing. I'm going to assume that if a parent, so we're looking at rows, if you're not sitting next to anyone, so basically if there's a parent here, that can't be next to it, can it? Yeah, I don't think you could fit 54 in. So I think what you're looking for is, parent, parent, blank, parent, parent, blank, parent, parent, blank, parent. So I think on each row you can have at most 7. So yeah, I don't consider these as next to each other. I think you're just talking, when you're saying sitting next to just one other person means on your left or your right. So imagine these parents are facing forwards. So you can have 7, 14, 21, 28, 35, 42, 49 parents in the first 7 rows. And so what you're looking for is you're looking for the row with the most empty chairs in adjacent empty chairs in a single row. So you can again have parent, parent, blank, parent, parent, blank, 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 parent, because you need 5 more parents to get to 54. So I think it's 4. You're squeezing as many parents on the row as you can. You can't fit another parent on a row, so you can't get higher than 7 parents on a row. And if you cram as many parents as you can, yeah.
The shower won't turn off.
Have you pulled the dank wire?
Yeah.
I'm streaming. I'll go sort it out afterwards.
Yeah.
So there's 4 blanks left. So I think it's 4. In the diagram, P, Q, R, S, J, Q, K, and L, R, K are all straight lines. What is the size of the angle J, K, L? I'm going to learn from my mistake and I'm going to make this larger. So let's just make this larger. And we're looking for the size of the angle JKL. So I'm going to cover the picture at the moment. So JKL. So we're looking for JKL. JKL is this one. So we're going to call it Z because they've already given you X and Y. So this is 2x. This is 2y because of angles on a straight line. This is 180 minus 2x minus y. And this is 180 minus 2y minus x. Okay, so my guess is you can't work out x and y, but my guess is if we work on this triangle alone, we might get something like x plus y equals, or like 2x plus 2y equals, and then we can just substitute it in for this bit. So if we can work out an expression for x and y together, or 2x and 2y together, we can work out z. So we're going to deal with this triangle here. We're going to get some space. So that triangle there is 180 equals all of those added together. So we know 180 equals, yeah, thank God I did a bigger diagram, says AJ. 180 equals 33 plus 180 minus 2x minus y plus 180 minus 2y minus x. So we're going to put the x's and y's on the left, and we're going to take 180 off the right. So we're going to get 3x plus 3y is 180's cancel, so you're going to get 33 and 180 is 213. This is divisible by 3, so we know that if we divide everything by 3, we get an x plus a y is 61. And because I know what's coming up, I'm going to say 2x plus y. I'm going to double everything. Gets me 122. 2x plus 2y. So we're looking at this. We know from this triangle here that 2x plus 2y plus z, the one we're trying to work out, is 180. But 2x plus 2y, from our other bit of information, is 122. So it's 122. Oh, thank you, Tim. 71. 142. Whether that would have been a wrong answer, we'll see. 142. Go here. 142 equals plus z is 180. So z is 38. So my guess is that an answer of 61 would have actually got me one that wasn't there, so I would have gone away. So 38 is there. It's the last one. Right, so I definitely got one question wrong because AJ pointed out an answer and I'd already gone wrong in it. So we are going to go back to the start. We're going to mark what we've done. So you obviously get your green pen out, and we're going to mark it. And in this particular case, now Tim, you might know this. In this particular case, there's no marks for getting questions wrong. So was that just this year gone? Because normally, even on the junior one, you get marks for the last 10. You lose marks if you guess them. So I think that's a new one, isn't it? A new error. Alright, here we go. So, put the answers up. We're just going to go through the answers. Alright, okay, right, got them well and I can see them. Right, so question 1 is E. Question number 2 is D. Question number 3 is C. Question number 4 is B. Question number 5 is E. I think I already ticked that. That's because we can check that one. Question number 6, is C. Question number 7 is A. Question number 8 is D. Question number 9 is A. Question number 10 is D. Question number 11 is E. Question number 12 is B. 13 is also B. 14 is D. 15 is E. 16 is A. 17 is E. 18 is B. 19 is E. 20 is D. 21 is D. 22 is E. 23 is B. 24 is also B. 25 is E. Now I thought I got one wrong. Which one did I think I got wrong? Yeah, so apologies, I got that one wrong. So because I underlined it already. Yeah, so 18 I got wrong. I misread the question first, and I want to correct myself. I missed one out, so got that one wrong. So let's go back to the start. Let's see what we got. We got question 18 wrong, so we got all the 5 pointers right. So we are going to get 15 lots of 5 points is 75, and we got one of these 6 markers wrong. So we got 9 6s, 54. So we're going to score 129. So we scored 129 out of 135. Did you do any better? If you did, post it in the scores. They changed it because it was a new online form. Oh, okay. Yeah. So I saw the ability to do this online. I imagine it marks it for you as well, doesn't it? I'm not going to do the online versions of these. I'm just going to stick to pen and paper effectively, or at least pen and paper as best I can. You picked me by 1:30. Yeah. I misread the question. And the annoying part is, when I misread the question, I didn't do a mistake, and then when I reread the question, I then made a mistake. Got the Venn diagrams wrong. Yeah, the Venn diagram one was nice actually. I'm not sure, as a paper, I'm not sure whether any of these questions are really, really elegant. I think they were okay. I think there was a few of them where maybe I went round a long way of doing it. I quite liked the trick on that one. There was going to be a quick way of doing it, and I was looking for it. The others will be close. This one will be close, I think. Be about 10 away between the differences. But yeah. Anyway, if you have had a go at this yourself and you did mark it, give yourself a score, give yourself a pat on the back for having a go at some good maths. And if you'd like to, you can put the comment in the comment section below. Please like, subscribe, share. I'm on Twitch. I will be doing these live on Twitch until I run out of papers. Or you can just have a go at the ones yourself, and you can follow me on YouTube. You can like either one of those. That's free for you. It helps me out. But I've been Steve, so thanks for watching, and I will see you soon.